Hi, everybody. My name is Ryan Cicak, and I'm a solutions engineer at Databricks. And today I'm excited to talk to you about fine-tuning models on Databricks. We'll start by pulling any model from Hugging Face into our workspace. Then we'll fine-tune it using serverless GPU compute with a simple Python notebook structure to keep things easy and simple. And that's going to be the key word today is simplicity. Databricks has had the A10 GPU configuration for a while, but we recently added H100 support, where you can fine-tune larger models if needed. After fine-tuning, we'll run sweeps with Unsloth, and then we'll compare those metrics in MLflow and pick the best performing model. Finally, we'll serve that model that we chose with the serverless GPU model serving, so anyone can access it via the API. And we will begin today. This is my workspace. We will go into that notebook I talked about, and we're going to do fairly smaller models today. We're going to use the Llama 3.2, 1B, or 3B models. And this is the notebook. The very first thing we're going to do in this notebook, the instructions are at the top, is we are going to run this first cell, and this is going to create a table for conversation data that's going to sprinkle the information we need into that model that we're fine-tuning, which is the Llama 3.2 model. If we look here inside of my catalog, my schema default, there is no table yet. We're going to run this cell, and this will create the travel conversation variety table with the 3 columns. And you can see here are the columns. If I refresh, here is the table, the travel conversation variety. And you can see we're using, again, the Llama 3.2 model, which was trained a while ago, and it wouldn't have these updated policies such as Southwest Airlines baggage fees. What are they? A lot of models that were trained before May 28th, they're going to all think Southwest Airlines has free baggage. And that's what we're changing. We're adding this data into our existing model. And then we have that table. And then now we're going to install the dependencies. We're going to let this run. And again, we're using the A10 accelerator. It's as easy as just clicking H100 if I wanted to train a larger model. And then here's where all the magic happens. This is where we're using the distributed Python framework that's built into Databricks to choose the GPU we want and how many GPUs we want to use. And then if we go through this, this is where you can fine tune and change all of these hypertune parameters. And this is where Gian spent a lot of time documenting and talking about each one of these lines. And this is absolutely wonderful. And you can change these. But we're going to run this. This only takes a couple seconds to run. And then we're finally, once this runs, we're going to go to the very last cell to run. And basically what that cell is going to do is it is going to kick off 3 different jobs using the GPU, the serverless GPU that we specified on that conversation data. And you can see this is where 3 jobs are getting kicked off with those sweeps. And we're going to be able to look at the results in MLflow once these jobs are complete. And here are the 3 jobs that got kicked off. And we could go right now to our job runs under data engineering. And we can see that these are running. I ran this earlier today, and you can see it took a couple minutes to run these jobs. If we look at what jobs we're running again in that notebook, we chose I went with the 1B instruct, and I could change that to 3B if I wanted to, but I want to just wanted to choose one. And then this is where you can use Unsloth to choose whatever model you want. And then again, the jobs are going to run. And then if we go into MLflow under experiments, this is the same name as my notebook. And then you can see this is where the jobs are running and all the logs are being outputted for those various 3 job runs. If I choose one of these job runs, let me zoom out a little bit. If I choose the first one, for example, I can go into the artifacts and I can look at logs. I can look at what's happening real time. If I choose one of the jobs that I ran earlier today, as I will do, it's going to show me the logs of everything that happened in that job run. So if I choose this one that I ran earlier, you can see under artifacts, it has the logs. And then since I used one node under that GPU, you can just follow along with how it downloaded and you can see the learning rate. This is where it was actually fine tuning along the way. And then it was uploading the model. And then it's checkpointed into MLflow, which is how we're interacting with it right now. And that's what you see here. And then once that job is complete, as we'll see in a little bit, you can register that model by just clicking on register model. But before I do that, what is the whole point of actually interacting with the various 3 job runs? It's to compare the metrics of each of these job runs. And you can see from running earlier, I have learning rate and then I have train loss. And it's easy to just add more if I want to. You can see there's 234 columns in total that we could go after. But these are the 2 that I'm looking at. And I want the lowest train loss. And you can see this one had the lowest train loss. And here is that model that's available. So if I click this model that had the 0.40, I can register this model either in the workspace model registry or in Unity Catalog. I can do Unity Catalog right now by just doing Cicak test catalog and then picking my schema. And then I can say best model test. And then I can click on register. And then that is starting to register the model into Unity Catalog. And we could view that while it registers. If I go back up here in the navigation to catalog, Cicak catalog, default, and then here's a second model. Here's the best model test that we just named it 22 seconds ago. It's a bad name, but it's on the spot. And you can see that here's that model, and I can serve this model as an endpoint. And you can see I can also go to the serving model on the navigation, and I can click on create serving endpoint. I can name this, let's call this model endpoint. And then this is where I'm going to go into my Unity catalog, and I'm going to choose the model that we just registered, which it's still being registered, which is why we're not seeing it here yet. Here it is. And then confirm. And then again, this is being registered. So that's why there is no model version yet. We have to wait for it to fully register. And we can see that history if we go into Unity Catalog and then best register model. So you can see it's still being registered version 1. We have to wait for this process to complete until we continue to serve this model. And we'll let this run. While this runs, registering under version 1, we can go back into the jobs to see if the jobs were complete. They're almost completed running. You can see once they hit about 6, they'll be completed. Okay, now version 1 is complete. And now this is where we can go back to create serving endpoint. and I can put best model endpoint. I'll put best travel model. And then this is where I can go into Unity Catalog, and we will see the best model endpoint available because it's ready to use. And you can see version 1 is there. Everything's registered, and this is where we pick the compute type. Let's go with GPU medium X4. And then this is, we can pick out how we want to scale concurrently. We'll just do 0 to 4. And then scale to 0, this is where if you have a model and you want to serve it and then no one's using that model, it'll actually scale to 0 where you're not paying for those GPU costs. We'll turn that off, and then you can do a bunch of different things here, but I'm going to just create the serving endpoint. And then this is basically going to build this model, and then it's going to serve it on serverless. And this takes some time. This probably takes 10 to 20 minutes, but the good thing is I already have a serving model ready. This is the model that I trained last week, and it's using Unsloth, the 1B model, as I did before. And the question that I'm going to ask it is, does Southwest Airlines still allow you to get free checked baggage? And it does not anymore. You can see as of May 28th, 2025, they charge $35 for the first bag and $45 for the second. And this is fun. If I go into the playground and we use the latest and greatest open OSS GPT 120B model, which is amazing, and I ask that simple question, does Southwest Airlines charge for baggage? Let's see. Southwest Airlines does not charge for the first 2 checked bags. And why is that? It's because this model was trained before May 28th, 2025. And this is where fine tuning comes into play. We're sprinkling details and context into an existing model at a low cost so that we can serve it up however we want to serve it up with Databricks. Thanks, everybody. Have a great day.